Welcome back. Today we're going to talk about determining whether relationships are proportional or non-proportional. Okay, so the first thing we want to go over is determining proportional versus non-proportional and linear versus non-linear. Okay, so the first distinction is between lines and curves. Now, what you're going to see is that I have three categories here. I have constant rate of change, passes through the origin, and I'll write this as graphs. Okay, so when you have these two, this should also be up in this category, but when you have two curves, what you're going to notice is that the rate of change between curves is not constant. So that's actually what distinguishes a curve between a curve and a line. And I want you to recall that in math class, when I say line, I always mean straight. Okay, it's not like art class where an art teacher might ask you to draw a line and you could draw, something that looks like this. In math class, this is not considered a line. A line is always straight. Okay, so if we have a curve, then the rate of change is not constant. If we have a line, then the rate of change is constant. Okay, the lines that pass through the origin are known as the proportional relationship. So this one passes through the origin. The line that does not pass through the origin here is a non-proportional linear relationship. Linear because the rate of change is constant, non-proportional because it doesn't pass through the origin. Okay, in linear non-proportional relationships, sometimes go through the origin and sometimes they don't, but it doesn't really matter because you've already distinguished them between as to not be a line because the rate of change is not constant. Okay, so we should be able to distinguish them also from a graph. So this graph shows the amount of sales tax that's charged based on the amount spent at a video game store in a particular city. Does the graph show a linear relationship? Is the relationship proportional or non-proportional? Well, it does show a linear relationship. I know that because it's a straight line, so the answer to this question is yes. Okay. Is the relationship proportional or non-proportional? The answer would be proportional because it goes through the origin. Right, so this point right here means that it is proportional. Okay, you are going to determine whether or not these are proportional or non-proportional in the quiz. I can't attach a picture to the quiz, so just use this as a way to answer the following quiz questions. Okay, you should be able to determine a proportional and non-proportional relationship also from an equation. So let's say the number of years since Keith graduated from middle school can be represented by the equation y is equal to a minus 14. So his current age, where y is the number of years and a is his age. Okay. So for instance, if he were 30 years old, he'd take his age and subtract 14. Y would be 16, so it would be 16 years since he graduated middle school. Okay. Is the relationship between the number of years since Keith graduated and his age proportional or non-proportional? Well, let's remember that when an equation is in this form, y equals mx plus b, that m represents the slope and b represents the y-intercept. Okay, so here I can force this equation to be in this form by putting a 1 in front of the a and then making this plus a negative 14. Okay, so since b is equal to negative 14, it does not pass through the origin, and it means that this is a non-proportional relationship because it does not pass through the origin. So essentially what ends up happening is it actually crosses at the point 0, negative 14. Okay, so the line will go something like this, and it doesn't cross through the origin like we would assume a proportional relationship would. Okay, so anytime when the b is not equal to 0, then it's non-proportional. Oops. Okay. Finally, we should be able to distinguish between proportional and non-proportional relationships in a table. Okay, so the value in the table represents the number of US dollars 3 tourists traded for Mexican pesos. This should have an S on it. The relationship is linear. Okay, so they tell us already that's linear. And they want to know, is the relationship proportional or non-proportional? Well, when you do this, it's all you have to do is, so let's think about this is going to be our X and this is going to be our Y, because they started with Mexican dollars and they received a peso. So just by the way, this is a 20 peso note, a Mexican peso note. This is what their 20, it's like our $20 bill, but they have 20 pesos. That's what it looks like for them. So we want to look at, remember, non-proportional relationships have a constant of variation, which is K. And K is always going to be the same. So K is determined by the ratio of Y to X. This is another way of looking at it. So if the Mexican pesos received over the American dollars, that ratio is constant, then it's always going to be, then it will be a proportional relationship. So 1,690 over 130 is actually going to be 169 divided by 13, which is 13. 3,315 divided by 255 actually also gives you 13. And finally, 6,565 divided by 505 also gives you 13. So all of these are proportional, so the ratio of Y to X is constant, thus it is a proportional relationship. Okay? Okay, now the reason why we do this is so that we can compare different types of, a lot of times that we want to compare different pricing schemes for different things. So let's say that a laser tag league has the choice of 2 arenas for a tournament. In both cases, X is the number of hours and Y is the total charge. So Arena A, the cost structure for Arena A is Y is equal to 225 times X, right? So Y is the total charge and X is the number of hours, okay? So it seems like Arena A is charging $225 per hour. Whereas, and there's no initial fee. Okay. Arena B has a different cost structure. So Arena B starts at, this would be a $50. So the initial fee is $50. And it is going up by, so for 1 hour, it goes to $250. So after an hour, after you paid $50, this is a rise of $200, okay, across 1 hour. So their per hour fee is a little bit cheaper than Arena A, so it's $200 per hour. Okay, now now that we've we've evaluated each of the cost structures, we've interpreted them in terms of the initial fee and the per hour cost, let's use some sentences to compare and contrast the two situations, okay? One thing you can say is that Arena B is cheaper per hour, right? It's $200 per hour, whereas Arena A is $225 per hour. But Arena B does have an initial charge of $250, okay? So, so if you're just going for 1 hour, Arena B is actually going to be more expensive, right? So I could actually make a table if I wanted to of the number of hours and the cost for A and B. Because we might want to know at which point does one arena get cheaper than the other. So after, at 0 hours, Arena A is costing 0 money, but Arena B has an initial charge of $50. At 1 hour, Arena A is just $225, but Arena B is $250, okay? After 2 hours, Arena B is $450 because it's $225 an hour. And Arena B is, so it's going to be $200 for an hour, so it's going to be 200 plus 200 is 400, plus 50 is 450, so they're actually the same. After hour 3, Arena B is going to be $675, or sorry, that's Arena A, and Arena B is just going to be $200 more than this, so it's going to be $650, okay? So at a certain point, so right at this point, Arena B, so before, at 1 hour, Arena B is more expensive than Arena A, but at 2 hours, the situation changes where Arena A is actually, at 2 hours, they're both equal to each other. At 3 hours, that's the dividing line between Arena A being more expensive than Arena B, Okay, so here is a point where they're both equal. And before this point, arena A was a better charge. And after this point, arena B is a better deal. So if you know, if the league is going to spend more than 3 hours at the tournament, then you know that you should be choosing B instead of A. Whereas if they're only going to spend an hour, then they should choose A. Okay. Okay, let's go over another situation. Jessica is remodeling and has a choice of 2 painters. In both cases, X is the number of hours and Y is the total cost. Compare and contrast the 2 situations here. Okay, painter A has, this is a proportional relationship, so the initial cost is $0. But the hourly fee is $45 per hour. Now, let me just write this a little bit better here. Okay. Now, painter B has an initial, this is not a proportional relationship because the y-intercept is 20. So that means the initial cost is $20. So before they even paint a room, the cost for showing up at the house is $20. Okay. Now, sometimes people do this to encourage like someone like Jessica from creating an appointment with them and then canceling once they show up at her house. So they'll say, well, even if I just show up, I'm going to charge you $20 just for showing up. That's to prevent any situation where the person cancels at the last minute. So their initial cost is $20, but then their per hour cost is a little bit different. So their per hour cost is $35 right here. Right, so the increase is $35. Every time the hour increases by 1, they increase $35. So it's $35 per hour. Okay. Now, what we can tell is that let's see. Let's move these words down here so I can. Let's move them down here so I can add some stuff to my table here. So at a certain point, depending on what Jessica wants, so if she just wants someone to come over and can look at her walls, she would choose painter A because they wouldn't be painting at all. If she wants to, let's see, if she wants to paint for 1 hour, so let's extend this table so that we can look at the cost structures of both of these painters. So, oops, this is already painter B, so we'll leave this one at B. And so painter A, for 0 hours, painter A is $0. For 1 hour, painter A is $45. For 2 hours, painter A is $90, and then for 3 hours, it is $135. They are $135. So here you can see up until hour number 1, if she only has an hour's worth of painting, it's easier for her to go. It's cheaper for her to choose painter A. If she has 2 hours worth of painting, they're both the same cost. Okay, if she has 3 hours of painting, it switches over to be cheaper for painter B. So at first, the first 2 hours, those are painter A is the choice. The second hour, both of them are equal, and in the third hour, painter B is cheaper. Okay, so that's a way to compare and contrast the cost of these 2 painters. All right, and that's the end of the lesson for today.